welcome to the video. Today we are going to solve another Math Olympiad problem. The problem goes like this. We have to find the integer value of this. So this expression is 1 divided by 1 by 2013 plus 1 by 2014 plus 1 by 2015 and so on until 1 upon 2022 plus 1 upon 2023. Okay, so let's get into it. So we will be using plasma method. First step is problem understanding. Now, we are required to find out the integer value of this number, of this expression. So it is not required to exactly calculate the decimal places, but we have to just look at the integer value, right? So that is clear. Now, from L, we have to link the concepts. Now, whenever you see a problem like this, where you have to find the integer value, that means that somehow this expression must be bound by some upper or lower term, lower numbers. So this is a boundary problem. Okay, where we have to look at the lower bounds and the upper bounds, and we have to see whether our whether we are able to get an integer value. If the bound is too high, then we have to find another way to narrow it down. Okay, so whenever so this looks a little surprising at the beginning, or a little daunting how to start solving this. First, let's see how many terms are there. So it starts with 2013 and ends with 2023. So there are 2023 minus 2013 plus 1. So there are 11 terms. Okay. Now, this is a very large number on the denominator. So this will be small. This whole thing will be, adding all of them, 11 terms will be much smaller. But then since these are small, so 1 upon this will make it again large. Okay. Now, what we have to, how do we approach this issue? This is, we look at the first term and then we look at the last term, which is 2013 and 2023, and all the middle terms like 2014 to 2022, they lie between 2013 and 2023, right? So they all lie between these two numbers, okay? As a number, I'm saying. Okay, if we look at their reciprocals, so 1 by 2013, 1 by 2020, 2014, 2014, dot 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 1 upon 2022, and then this is 1 upon 2023. So when we take the reciprocal, the signs will reverse, the inequality will reverse. So instead of this being greater than this, now this is going to become greater than this. So the inequality will reverse when we take a reciprocal. So that is something that we need to keep in mind. Okay. Now we know that all of these numbers are less than 1 upon 2013. So let's try to do one thing here, that we assume that this whole summation of reciprocals, let's call it R, the reciprocal, right? So this R, each of those terms will be less than 1 upon 2013. So each of those numbers is going to be less than 2013. So R is going to be less than 1 upon 2013 times 11. So there are 11 terms and all of those numbers are less than 2013 except this whole number. But then all the 10 other numbers are less than this. Okay. So this is what we know as our upper bound for this r in the denominator. Again, if this is so, then 1 by r is, now we have to flip the sign, it will become greater than 2013 divided by 11. Okay, so this is what we got as our first equality. This is the same as what we are looking for. Let's call this sum S. So this is what is our sum. S is equal to this. So this is greater than 2013 by 11. Okay. Similarly, the other way is R is, all these numbers are less than 1 upon 2013. Now, if we look at this part here, so all of these numbers are greater than 1 upon 2023, right? So that means the reciprocal of it, which is S, now this is 1 upon R, is S. This has to be, we have to flip the sign and we have to flip the right hand side, 23 by 11. Okay. So now we have this where S is greater than this, and we have this where S is less than this. So let's try to find what are those numbers. So I'll erase this. S is greater than 2013 by 11 and less than 2023 by 11. Okay. Now let's calculate what this is actually. So 2013, when it's divided by 11, we have 1, so which is 11, then 91. So 8 times 88, so 33, so 3 times. So this evenly divides. Now let's see what this is. 2023 by 11. So 1 times 11, 92. 8 times 88, and 43. 3 times 33, and 100. Dot 9 times 99, and so on. Okay. So what we see here is our S is less than 183.9 and greater than 183. Okay. So from here we can definitely say that the integer value of S is going to be 183. 183. And that is our answer. Okay, now this is the Math Olympiad problem. Now let's take it one step further and assume that we have to get the first digit after the decimal. Can we do that? Let's see how to do that. So now we have to think a little bit differently. What we see is we have 11 terms, correct? So there is some term here in the middle, and then there are 5 terms on the left of it and 5 terms on the right of it. For this case, there are 11 terms, correct? So the middle term is going to be 1 upon 13 and 23 is 10 apart, so 5 you add, so 2018. Then we have 19, 2020, 2021, 2022, 2023. Okay. Then on the left of it, we have 2013, 14, 15, 16, 17. So 5 here and 5 here. Okay. Now, what we can do is we can likely look at the numbers which are one left and one right. Let's say if we take the number which are one left and one right, somehow their addition will give us the numerator. In the numerator, they will be added, right? 1 upon 2017 plus 1 upon 2019. The numerator will become 2017 plus 2019 divided by 2017 times 2019. Okay? And then the numerator is actually 2 times. So this is one less and one right of 2018. So essentially this becomes 2018 plus 2018 or 2018 times 2. And then in the denominator we have 2017 and 2019. Okay. Let's do it for the other term, which is 1 upon 2016 and then 1 upon 2020. What I'm trying to do here is I'm trying to create something which is where the numerator gets common. We are slowly summing them up, but at least we have to take out something from the numerator or from the denominator. Here, one possibility is if we split it around 2018, then we can take out the numerator. So this will become 2016 plus 2020, which will become 2018 times 2 again. And in the denominator, we have 2016 and 2020. Okay. Still, there's a lot where we are going, right? It's a long way. So after this, what we have to do, I mean, once you sum it up, then how will it look? From the term which is right around it, we will have 2018 times 2 upon 2017 times 2019. What can we do here? This is actually 2018 minus 1 and this is 2018 plus 1. Okay. So essentially this is 2018 square minus 1 square. A minus b into a plus b is a square minus b square. Okay. So this becomes 2018 into 2 divided by 2018 square minus 1 square. Okay. So the next term will become 2018 into 2 divided by 2018 square minus 2 square, because the 16 and 20 will become 2018 minus 2 and 2018 plus 2. So the next will become 2018 into 2 divided by 2018 square minus 3 square. Then the next will become 4 square. Then it will become 5 square. And then once this and this will become 5 square. So now we are left with the only single term, which is 2018. That is still remaining. So now what? Now we know that on the numerator again we have 2018. Let's change this to become 2018 square, and you will multiply and divide 2018 on this also. Now I think 2018 square is going to be a really big number. Okay. Now we have to do some kind of an approximation here. This is a very big number. So against 1. So if you remove 1, this is not going to be too different. So I think we can ignore this 1 square, 2 square, 3 square, 4 square, 5 square. Let's just ignore these. Okay. So then what we will have is, why I'm ignoring? Sometimes when the other quantity is too large, this will become insignificant. That's what, in the limits also we use that theory. That's why I'm ignoring this. Okay. So then what eventually we are left with is 2018 square in the denominator for all of them. So all these 2018 will get cancelled. So what eventually we are left with is 1 upon 2018 times, so 2018 will get cancelled here. 1 upon 2018 is out, so this becomes 2, plus here also becomes 2, plus 2, plus 2, plus 2. 5 times 2, and then plus 1. Now I can remove this. So now it looks like this. So this will become 11 by 2018. This is approximately equal to, and then that's what we say. We are now approximately equal to 2018 by 11. So 1 by r is approximately equal to 2018 by 11. 11 is the same, but here the number, instead of 2013 and 2023, we have actually replaced it with 2018. So if we calculate 2018, we divide it by 11. So this will be again 1, 8, 3.4, 5, and so on. So this gives us 183.45 and so on. Our objective was to get the first decimal place, which we have approximated to be 4. But you know what the actual answer of this is? It is also 183.45. So we are pretty close to the actual answer. Okay. So we looked at 2 ways to solve a problem. One was actually bounds, and the other one is we did some manipulation and then we did some approximation. This will help in the certain exams. This can help to get to decimal place approximation. Okay. Hope you like this video.